All right, these are the notes for 10-7. So I'm going to start here in a basic idea of what we did before. So what value of x would make these equations true? So what would you plug in for x here? And I'm hoping that you would say x equals 0. Because the only way to get 0 is if one of the numbers here is 0. So the factors here would be 5 and x would have to be 0. Now in this one, if I said, what do you need to do to get 0? A lot of you would distribute, okay? But let's look at the factors. What am I multiplying? I'm multiplying 3, and I'm multiplying x minus 2. Well, there's no way I can turn 3 into a 0, and the only way to get something to equal 0 is if one of the factors, 3 times 0. All right, so I'm going to look at this parenthesis and say, well, what could I plug in for x to make this equal 0? Okay, what could I plug in to make this equal 0? And I'm hoping you'll say 2. The same idea can work here. Yes, you can distribute, but also let's look at the factors. In order for something to multiply to be 0, one of the 2 things you're multiplying, or 3 things you're multiplying, or 4 things, one of the factors has to be 0. Well, I can't change the 2. 2 is 2. But what could I plug in for x here to make it equal 0? And the answer would be -4. And that's what makes 0 such a beautiful number, and it's used so often, because if you're looking at factors that multiply to equal 0, we are guaranteed what one of them is. That's very unique to 0. For example, if I did 1, there's a lot of options of 2 things that could multiply to be 1. I could say 1 times 1. I could say 2/3 times 3/2. That equals 1. I could say 2 multiplied by 1/2. There's too many choices here. But when I say what multiplies to be 0, well, you know for sure one of these blanks is 0. And we're going to use that idea. So here we're solving quadratics by factoring. So if a times b equals 0, what must be true about a or b? That means a equals 0 or b equals 0. And we know that's what we just talked about. A reminder about what does quadratic mean. It means the highest exponent is 2. So we're solving. Factoring can actually work sometimes on the cubics and quartics. We don't know how to factor those yet, but that's coming soon. So we've learned several ways to solve quadratic equations. Factoring is the one we're going to learn today, but don't forget we've also learned quadratic formula and completing the square. All of these lead to the answer. They're just different methods, and there are different times where each one is useful. So we have to be flexible about which one we want to use when. All right, in the first one, I have x plus 1 times x plus 5 equals 0. So what are the factors? What's multiplying to be 0? This and this. So if I could make this 0, it doesn't really matter what that is. 0 times anything is 0. So what I'm going to do is I'm going to say, what would make this factor equal 0? And what would make this factor equal 0? And I kind of underlined these nicely before. So what would make this equal 0? And what would make this factor equal 0? So looking at each one, solve the equations, which I think you can do that, and you get -1 and -5. So if I plug in -1, I get 0 here. Plug in -1 over here, I get 4. 0 times 4 is 0. That works. And again, if I plug -5 in, I'll get 0 here. I won't get 0 over here, but that's okay. 0 times anything is 0. This one, the same idea. You're going to take each factor, okay? What would make this factor equal 0? What would make this factor equal 0? Because there's 2 opportunities. And then you're going to solve, and you will get 2 answers. You could get these 2 answers by multiplying out and doing a lot of different pieces to it, but we don't need to do that here. So I'd like you to try these 2 on your own. Push pause, then come back and you can check your answer. Right. So here are the answers to these. And we did check these on Desmos by setting y equals one side of the equation and y equals 0 and seeing where they intersect. This one's kind of cool. It has actually 3 different answers. And if you look at the graph of this, it looks very cool. We haven't done the cubic graphs yet. So here are your answers to the first, and here are your answers to the second. On the next slide, we're looking again, you have to make sure it equals 0. If it doesn't, use your algebra properties to make it equal 0. So that, because we need it to equal 0, that's our magic number, why it's so easy to figure it out. Then you're going to see, you're going to factor the left side, and we need to check if we can. So one quick way to check, I'm going to show you another way when we get into something called the discriminant, is to take the number here in front of the x squared. So here it's a 1. Multiply it by the last number, it's negative 2. 1 times negative 2 is negative 2. Can you think of 2 numbers that multiply to be negative 2 and add to be negative 1? Hopefully you're saying yes, negative 2 and positive 1. If you can say yes to that, that means you can factor it. So you're going to factor the left side. Okay? So this and this are the same thing. It's a different costume. I just took this and factored it. They mean exactly the same thing. If you graph them, they would be the same thing. I just made it look differently. And then I set each factor equal to 0 and solved. So it's very similar to what you did before. We're just having that extra step of having to factor it. As we come down here, you're going to do the same thing, make sure it equals 0. Again, to check if it can be factored, because sometimes it can't, 2 times negative 3 is negative 6. Okay, can you think of 2 things that multiply to be negative 6 and add to be negative 1? Okay, and that's, you can. Negative 3 times 2 is negative 6. Negative 3 plus 2 is negative 1. So you said yes, that means you can factor it. So you're going to factor it. Go back to chapter 5 notes if you don't remember. So we're going to factor that. And again, we're going to set each factor equal to 0, and we're going to solve. Okay, try this one on your own and come back. All right, and again, I factored it, set each factor equal to 0, and that means if I plug negative 4 in here, I would get it equal to 0. If I plug in negative 5, the expression would equal 0. On the next slide, we're going to do the same idea. So again, check if it's factored. 3 times 5 is 15. Can you think of 2 numbers that multiply to be 15 and add to be 8? Yes, 3 and 5 multiply to be 15, and 3 and 5 add to be 8, so that can be factored. So you're going to factor it. Again, you can push pause, try this on your own. So you're going to factor it. You're going to set each factor equal to 0. What would make this factor equal 0? What would make this factor equal 0? And you get your answer of negative 5/3 and negative 1. In this problem, 2 times 12 is 24. Can you think of 2 numbers that multiply to be 12 and multiply to be 24 and add to be 15? So let's see, 1 and 24, multiply to be 24, 2 and 12, 3 and 8, 4 and 6. So I just looked at all the things that multiply to be 24. 2 times 12 is 24. Do any of those add to be 15? No. That means we can't factor it, but it doesn't mean we can't solve it. It just means you're not going to be able to use factoring to solve it. So instead of using factoring to solve it, I have to go to my other methods, maybe completing the square, maybe quadratic formula. So you can go ahead, use quadratic formula, and come back and check your answer. Okay, so it cannot be factored, so I had to go to quadratic formula. So this does have solutions. It's just that you couldn't solve it by factoring. So just because you can't factor it doesn't mean there's no solution. All right, you can try the bottom 2 on your own and then come back. All right, in this one, notice that it doesn't equal 0. So we have an extra step first. We have to subtract 3 from both sides because I need it to equal 0. I'm looking for factors that equal 0. It makes my job much easier. Okay, then you're going to factor it. You can see I did that here and set each factor equal to 0. Over here, again, I checked to see if I could factor it. 1 times 20 is 20. Do I have 2 numbers that multiply to be 20 and add to be negative 2? No, I couldn't do that, so I went to quadratic formula. So cannot be factored, went to quadratic formula. I plugged all my numbers into the quadratic formula, and I got a negative, square root of a negative. And Algebra 1, we're not ready for that yet, so that is a no solution. So you can still get no solution. I wanted you to see that, but just because you can't factor it doesn't mean there isn't a solution. This one did have 2 answers. This one didn't. Quadratic formula showed that with a negative under the square root. So that is